Okay, to prove my statement that it's very simple to start with RFID and to have a look by yourself and to be able to trust the products you already use, I want to show you a very nice hack of Henrik. This is my favorite hack in the RFID world because it shows you the simplicity of an attack. This is actually an RFID sniffer. It's a piece of paper, basically. You only have a few turns, which are basically some rule of thumb, how many turns you have to do. These are simply glued with tape to the, you see a hand-drawn schematic of the circuit, which consists of exactly 3 parts, which is the coil, the diode for rectification, and a capacitor for smoothing the resulting signal. And this you can simply connect to your PC and you can immediately start sniffing 100 kilohertz RFID tags. So they are very widespread in door systems, for example, or for example in key fobs for cars. So you can just spend a few cents on parts and you have a perfect RFID sniffer. And the average sound card does the job. You may think that this is already cool, but it's much, much cooler. Henrik did a second device. As you see, same concept, same paper, same coil. You see only one device more, which is a MOSFET. You have to think of a MOSFET like a relay, where you set power to it and it just shorts the circuit. This is used to emulate a RFID card. Okay, you may think these two things are cool, but you have to imagine this thing plugged to an iPod, recording an RFID transmission, and then replaying the very same transmission by using the very same iPod, and clack, the door opens. So this is, in my opinion, the coolest hack ever. Okay, so you have no excuse not to take part in RFID security research. Okay, the next step is some of you may have an oscilloscope. The problem is that with higher bit rates, your average sound card isn't fast enough. Average sound card can sample at 48 kilohertz, so you basically can sample data up to 24 kilohertz, which is exactly half of the sampling rate you have in your card. So to examine this high-end cards like MyFair, which work in 13.56 megahertz range, basically the antenna is the very same. I think, to my opinion, antennas, RFID antennas don't deserve the name RFID antenna because it's in fact no antenna at all. Like Henrik already explained, it's basically one end of a transformer, and that's all. So it's very simple to build. You may have fear of building antennas because there's always foo spread around building antennas, and there is a lot of secrecy around. But building an RFID antenna is very, very simple because you basically build a transformer. You don't even need a core or something like that. So the most simple antenna you can imagine is just you take your oscilloscope probe, take your ground connector, and just connect it to the pin of your probe. That's all. This single loop, it's obviously not tuned, nothing. It's already a very good loop antenna. You can immediately start sniffing RFID signals with a simple oscilloscope. It's a bit hairy to find the trigger level, but as you can see, you see a very nice picture, and with some practice, you can immediately read the bits that are transmitted. And this is definitely possible. It took me, say, several hours to figure it out because I'm not that fast, but I think you can figure it out much faster. Yeah. Okay, this is basically what I said. You just place the this loop antenna between your RFID reader and between your card. The point is that if you want to attack a specific RFID system, you don't know if it's one in the 100 kilohertz range or if it's one in the 13.56 megahertz range. To find this out, it's the most simple way is not to play around, but simply take an oscilloscope or frequency counter. This would be also enough. You can build a frequency counter very simple by using, there are cheap ICs available that do counting and just use the least significant bit for letting an LED blink, and you immediately see if it's a 100 kilohertz carrier or if it's a 13.56 megahertz carrier. So also no excuse for equipment prices. And for testing and get quick results, I suggest you to take a known system and make constant transmission and try to get a feeling about how adjusting the trigger level. And you will see it's very, very simple. Okay, with the data you see, you can, by figuring out what modulation patterns are used, what type of card you have, and then you can use your RFID reader to access this card. And you can verify if it's a well-known card at all. There are plenty of RFID cards out there which are not documented at all, and they are probably can be hacked easily because nobody yet tried to hack them at all. So it's definitely worth to have a look what happens on the air. A very nice check which can be simply done is you simply look how long the transaction is. Most RFID, or some, no, most is wrong, they learned a bit in the last years, but I say more than half of the RFID door systems out there still work on a UID-based scheme, because common knowledge is that you can buy one card and you can't buy the second card with the same UID. So it's widely regarded as a security scheme to just check for the UID. But obviously, you already saw it in Henrik's part, the UID is not protected against reading. So you once sniff a valid RFID UID, you can sniff this over range because you don't have the intention to influence the rear field, and then you can just take your simple device and replay it, obviously with the proper timing, but this is no security system. So what, if you want to implement such a system on your own, then you want to stick to a cryptographically secured card, and even MyFair standard is much better than a UID-based scheme, obviously, at least till we find out how Crypto One works. But you have to make sure that there is a authentication between reader and the card. And if you see that only few bytes are transmitted, then it's not possible to do such an authentication. Maybe they do some foobar, and you have to sample some test samples, and you can reply accordingly without even knowing what the protocol actually means. Okay, so short transactions are a clear indication of that something going wrong. You also can see if the packets are changing with each transaction, because this is a clear indication that we are talking probably about a cryptographic implementation. So this can be also verified by using a cheap oscilloscope. Okay, I want to dive deeper into building loop antennas. As Henrik already shows, loop antennas are very simple, and basically, to a given radius at least, you can, by increasing the diameter of the loop antenna, you can increase the range directly. So there is a certain limit. I won't go deeper into that, but to a certain level you can increase it. And you can build this cheaply. So in the worst case, you just take some 2 pieces of wood and build just a bigger loop, and that's all. To increase the gain of the antenna, you must tune it. So if you tune it into resonancy, then you get a much higher range. The range quickly increases by a factor of 4. So it's definitely worth to tune your antenna, and tuning your antenna sounds difficult, but it isn't in fact. You can, because you're only sniffing and not transmitting, you can buy very cheap capacitors that are tunable and just plug in one end of your antenna, and you can use a simple voltmeter to check where the resonant frequency is. And it's a pretty sharp tuning, but you can, for example, by adding two capacitors in parallel, one very small tunable capacitor, one huge capacitor, you can tune in the rough area, and then you can fine-tune with the small capacitor. So there is no rocket science behind it. So just try it. If you want to do serious attacks with long range, obviously you want to have as few as noise as possible. You can buy ready-made operation amplifiers, which come in, even if you are not so good in soldering, they come in this dip housing that you can stick in breadboards. It's very simple, and you put them as near as possible to the antenna and just buffer the signal for a starter. So it's a very, very simple circuit. Yeah, and if you want to see how such an FHF example of such an FHF front end, you want to have a look at the OpenPICC schematics. OpenPICC, I will explain it later, is our RFID sniffer and soon to be RFID emulator. So just take the HF front end. There is already proven, so you can just copy and paste it. If you want to do high sophisticated attacks where you want to correlate multiple samples, which is also a nice possibility to get rid of all the noise, you just sample, say, if you're lucky and you have a transaction which is basically mostly the same, you can sample it 10, 100 times, million times, how often you want, and then just by overlaying it, you get rid of all the noise. So this is very simple, and if you're not so good in programming, you can even do it in Star Office or in OpenOffice with a spreadsheet. So there is also no rocket science behind it. Okay, and a very nice tool which I can highly suggest you is GNU Radio. We love it very much. You probably will look on the website of GNU Radio and will find out that you think that's fucking expensive, but it's very cheap, in fact. It's around 700 euros, but it replaces a whole set of tools. It's a highly sophisticated spectrum analyzer. You can capture any frequencies up to the gigahertz range. You can replay any frequencies up to the gigahertz range. You can use any modulation patterns you want. And the nice thing is that you do everything in software. You don't need to solder anything. You just have GNU Radio, have a nice set of Python objects, just connect them, and they usually do what you want. GNU Radio is very powerful. It can even decode HDTV transmissions. So it's a perfect tool if you want to find out what's going on also in other RF protocols. And yeah, you get very quick results with this. So to be able to make a security evaluation more simple, there was one option to reverse engineer existing reader, but we said, oh no, we don't want to do this, because usually after you reverse engineer something, half a year later you have to buy the next one because it's not on stock anymore, and you start from scratch. So we decided to build our own reader, which is optimized for security evaluations. So basically we built a reader which uses a common chipset, RC632 from NXP, and it basically does most of the work and the hairy work on RFID, 13.56 megahertz protocols, and the nice thing is it also supports MIFARE. So this a proprietary protocol Henrik mentioned before is inside this chip. So you have a very nice system where you have a black box where you put data on one side in, and on the other side you can analyze it. So and to make sure that it's community compatible, we make sure that you don't need any special programming equipment. You just use your Linux PC. You have a standard ARM toolchain. It's a 32-bit ARM controller. Harold Welter created a very great library called